friends, welcome back to my YouTube channel. So in this session, we will try to remember the formulas related to resistors, inductors, and capacitors, which can be either connected in series or parallel, both. Okay, so this is the why the main reason to conduct this session is all things we will collectively try to remember so that it is very easy and a bit not confusable also, so that maybe it is whichever is required, we can use it as per requirement. Suppose for example resistors can be connected in series or parallel, so depending on the requirement or after analysis which formula we can apply, we can directly remember in this way. Okay, so both or all the three, that is resistors, inductors, and capacitors. As we know, I have already conducted many sessions on resistors, inductors, and capacitors, but now all put together, how to remember the formula is the main topic here, because these are frequently many of the circuits will be given in any of the competitive examinations and asked to for 1 mark or 2 mark, and asked to solve or find out any of the unknown value. So in that particular case, the remembering of the formula becomes very important. Okay, of course, you can derive also, but still, deriving is not suggested because the time factor is very important in competitive examinations. So, keeping that particular thing in mind, we will try to quickly recall the formulas of all the three resistors, inductors, and capacitors connected both in series, either in series or parallel. So, let us quickly start with the session. So, resistors in series, if the resistors are connected in series, okay, then the equivalent resistance in the circuitry is the addition of individual resistances. Means if multiple resistances are connected in series, then we have to add or sum up all the resistance values to get the equivalent resistance value of the circuitry. Okay, so this is the main thing. So in the similar way, if the resistors are connected in parallel, the equivalent resistance in particular of that particular circuitry is given by the reciprocal of equivalent circuit is given by the addition of reciprocal of the individual resistance values. Okay, so resistance in series, addition, resistors in parallel, the reciprocal of taking reciprocal of all the things. Okay. Yes. Then inductors in series. So inductor L equivalent is the equivalent inductance value. So in case of series, again in the similar way, resistance and inductance both are calculated in the similar way. I mean to say that is resistance also in series we have to add the individual resistance values. In case of inductors also we have to add the individual inductance values. And in parallel also reciprocal, and in parallel inductance also reciprocal. Same thing, nothing to confuse here. Resistance, inductance, same. Okay, so here L equivalent is if you want to calculate the equal, if there are multiple inductors in the circuit and they are connected in series, then L equivalent is given by L equivalent is equal to L1 plus L2 and so on up to Ln. So we have to just sum up the sum of all the inductance values and we will get the equivalent inductance value. So similarly in parallel, reciprocal of the inductor equivalent is nothing but addition of the individual uh, inductance values. Okay, so L 1 by L equivalent is nothing but 1 by L1 plus 1 by up to 1 by Ln. Okay, so in this way, resistors and inductors behave in the same way. That means if resistors or inductors both are connected in series or parallel, the behavior is same. That is, in series, if resistors are connected, add it. In inductors also in series, add it. In the case of resistors and inductors in parallel, just take the reciprocal of equivalent and add the reciprocal of the individual resistors or inductance values. I hope now resistors and inductance there is no confusion. But in capacitor, it is opposite to whatever we have done. So if capacitors are connected in series, then take the reciprocal of the capacitor as we have done in parallel in case of inductors and resistances. So 1 by C equivalent is nothing but 1 by C1 plus 1 by C2 up to 1 by Cn. So capacitors in parallel we have to add it. C equivalent is nothing but C1 plus C2 up to Cn. So this is all regarding resistors, inductors, and capacitors. So please remember in this way, resistors and inductors in series we have to add the individual values. In parallel we have to take the reciprocal of the individual values, and then we have to we will get the reciprocal of the equivalent values. But in case of capacitors, it is opposite way we have to remember. In series only we have to take the reciprocal of the equivalent, and we have to add the individual equivalent values of the individual values of the capacitance values. And in case of parallel we have to just sum up the capacitance values in the circuitry. So in this way, it is just a a recalling session. Like it will be helpful for any of the examinations or any of the to remember the formula just in a easier way. Okay, so if you are not yet subscribed to my YouTube channel, please subscribe to my YouTube channel and press the bell icon to get the latest updates. Okay, so thank you, have a nice day, bye.